Have you ever thought about what it would be like if a single weather event could decide the fate of more than 1 billion people? Well, that's not science fiction. That's the Indian monsoon. It's this massive, planetary-scale engine that literally powers a subcontinent. So, let's deconstruct this incredible phenomenon together.
And I mean, this is so much more than just a rainy season. It's a life-giving force, and sometimes a life-taking one. It shapes the destiny of an entire nation. You know, a good monsoon can actually boost India's GDP by 2%. But a bad one? That can set off a domino effect of crises, both economic and social.
And to really get a sense of its raw power, just look at this number, 75%. In just 4 short months, this one system delivers 3/4 of India's entire annual rainfall. It's not an exaggeration to say it's the absolute lifeline of the subcontinent.
Okay, so we've established it's a lifeline. But what does that actually mean on the ground? How does this massive weather event directly impact the lives of over 1 billion people? Let's take a closer look.
This right here, this tells the human story behind the monsoon. Almost 2/3 of India's entire population depends on agriculture for their livelihood. So for millions and millions of families, the monsoon isn't just a weather pattern, it's everything. Their fortunes, their survival, it all rises and falls with the timing and intensity of these rains.
So, what's the science behind this spectacular annual event? How does this massive continental engine actually fire up year after year like clockwork? Well, let's dive into the fundamental physics that gets it all going. You know, the word itself gives us a huge clue. It comes from the Arabic word musim, which just means season. And that's because, at its very core, a monsoon is just a massive, seasonal U-turn of the winds. It's all driven by one really simple but powerful idea. Land and sea heat up at different speeds. So here's how it works, in 3 basic steps. First, as summer kicks in, the enormous Asian landmass just bakes under the sun, right? It gets way hotter, way faster than the Indian Ocean. Second, all that intense heat makes the air above the land rise up, creating this huge zone of low pressure. And third, well, nature hates a vacuum. So cooler, heavy, moisture-packed air from the high-pressure zone over the ocean rushes in to fill that gap. And that massive inrush of moist air, that as the monsoon. But what actually triggers this whole process? What flips the switch? The answer is something called the Intertropical Convergence Zone, or ITZ. Just think of it as a band of low pressure that circles the globe near the equator. As the sun moves north in the summer, this band follows it. It acts like a giant master switch, or maybe a giant vacuum cleaner that just sucks those monsoon winds right into the Indian subcontinent. Okay, but the monsoon is way more than just a simple heat engine. It's actually a super complex symphony of different atmospheric forces. So now let's meet the key players in this grand orchestra. This map gives us a fantastic bird's-eye view of what's going on. You can see these powerful winds starting way down south from what's called the Mascarene High. That's a huge high-pressure system that basically gets the whole engine started. From there, those winds get funneled into the Somali Jet, which is like a high-speed current that blasts moisture across the Arabian Sea. So let's break down 2 of those key players. Far to the south, you have the Mascarene High. Think of it as a giant dome of high pressure that acts as the source, giving that initial powerful push to all that moist air. Then, as those winds travel north and cross the equator, they get organized into the Somali Jet, a low-level atmospheric river that's basically a super-fast conveyor belt, rocketing all that moisture right towards India's west coast. And then you have the Tibetan Plateau. This thing is an absolute game changer. As the famous meteorologist Dr. P. Kotoraram pointed out, this huge, high-altitude landmass acts like a giant solar panel in the sky. It soaks up the sun's heat, creating this powerful updraft that doesn't just pull in the surface winds, but it also fuels the entire upper air circulation that keeps the whole monsoon system running for months on end.
All right, now we're going to zoom way out. Because the monsoon isn't just a local show. Oh no, it is deeply connected to things happening thousands of miles away. You have these global climate patterns that act like puppeteers, pulling strings that can make the rain stronger or weaker each year.
And at the heart of these global connections, you've got El Niño and La Niña. They're 2 opposite phases of a climate pattern in the Pacific Ocean. So during an El Niño, you get warmer water in the eastern Pacific, and that tends to mess up the atmospheric circulation, usually leading to a weaker monsoon and a higher risk of drought in India. La Niña is the total opposite. Cooler waters which tend to supercharge the monsoon and bring more rain. So this table gives you a nice clean summary of how that all works. But wait, there's another major player in this global chess game, the Indian Ocean Dipole, or IOD.
A positive IOD with warmer waters in the western Indian Ocean can actually give the monsoon a boost. And what's really fascinating is that sometimes a strong positive IOD can cancel out the negative effects of an El Niño, which just adds a whole new layer of complexity for forecasters.
But here's the thing. This intricate, finely tuned engine, with all its global moving parts, it is now showing serious signs of stress. Our changing climate is making the planet's most vital weather system more erratic and, frankly, a lot more dangerous.
What you're looking at here really paints a stark picture of this new reality. The whole system is becoming more volatile. We're seeing longer and longer dry spells, broken by sudden, terrifyingly intense downpours. This feast-or-famine pattern is just devastating for agriculture, causing both water shortages and destructive flash floods.
The overall trend is pretty clear. The monsoon is weakening. Over the last 50 years or so, the total amount of rain during the summer has dropped by about 6%. Now, that might not sound like a lot, but for a country that's already struggling with water stress, it is a significant and really worrying decline.
But, and here is the dangerous paradox, at the very same time, the number of days with extreme heavy rainfall over central India has shot up by a staggering 75%. So we're getting less rain overall, but when it does rain, it's coming down in these destructive, flood-inducing bursts.
And the impacts aren't being felt evenly across the board. It's a complex picture. Some regions are actually getting wetter, while others are getting drier. And what's really concerning is that many of the areas seeing less rain are the most important agricultural lands, like the Indo-Gangetic Plains. This geographic shift is a massive challenge for farmers and policymakers.
This new, unpredictable reality presents a monumental challenge. It's not just for the scientists trying to predict it, but for the hundreds of millions of people who for centuries have depended on its ancient, reliable rhythm.
And the scientific challenge here is just immense. I mean, this incredibly complex dance between the oceans, the atmosphere, and the land is what makes the whole system work. And it's precisely those delicate interactions that our current climate models really struggle to capture accurately enough to give us reliable forecasts in a warming world.
And that leaves us with this final critical question. As this life-giving rhythm becomes more volatile, more extreme, and less predictable, the challenge of adaptation for over 1.4 billion people is not just some academic problem. It's one of the most urgent questions of our time.